Hello and Assalamu alaikum guys. In this particular video, we would be trying to see how to analyze or sketch graphs of kinematics. Before we start off with the topic, we need to identify some certain graphs and how to analyze these graphs, specifically their gradients. So if I look at this first graph, I can identify that the value of y is remaining constant. Plus, it's a horizontal line, so if I find out its slope, it would be equal to 0. When I look at these two graphs, in one graph, the value of y is increasing, and in the other graph, the value of y is decreasing. But since it is a straight line graph, so I can say its gradient or slope is constant. So here we have a constant positive slope, and here for this particular graph, we have a constant negative slope. Whereas when we look at these two graphs, this is the one in which the slope is increasing. How can I analyze that? So when I draw two tangents, I'll see that when I go further ahead in graph, the tangent tends to become more steeper. So I'll say y is increasing and also increasing at an increasing rate. Similarly, if I look at this graph, y is decreasing and the tangent that I draw further ahead is more steeper. So it has a larger gradient. So in this particular graph, the value of y is decreasing at an increasing rate. Now, when I look at this particular graph, I can see that the value of y is increasing. But if I draw two tangents, one in the beginning and one further ahead, then I will identify that the tangent becomes less steeper and hence the gradient is decreasing. So I will say y is increasing but at a decreasing rate. And similarly, if I look at this particular graph, the value of y is decreasing, but a tangent in the beginning is more steeper and the tangent later on is less steeper. So here, the value of y is decreasing at a decreasing rate. So not only should I be able to identify whether quantity is constant, increasing or decreasing, I should also be able to identify whether it is changing at a constant rate, increasing rate, or decreasing rate. For straight lines, the quantity changes at a constant rate. For curves, if this graph becomes more steeper, then it would be changing at an increasing rate. Whereas if the graph becomes less steeper, then I'll say that it is changing at a decreasing rate. Now let's see how we relate this with the graphs of kinematics. So the first type of graphs that you need to understand over here are distance time graphs, where we plot distance on the y-axis and time on the x-axis. So if I see that it's a flat horizontal line, this means that as the time increases, the value of distance is not changing. And hence, this represents a body being at rest. The slope of a distance time graph represents speed because speed is the rate of change of distance. So if I look at this particular graph, the distance is increasing. Hence, the body is moving. But since it's a straight line, so its slope is constant. And since the slope is constant, I can identify that it is moving with a constant speed. So distance is increasing at a constant speed. Whereas if I look at the next graph, I can still see that the distance is increasing, but it's a curve. That means that the slope is not constant, which means speed is not constant. And if I draw tangents, I can see that the graph is becoming more steeper, and steepness is the measure of speed in distance time graph. So the body is moving with increasing speed. If I look at this final graph, still the distance is increasing, but the slope of the graph is decreasing, which means that distance is increasing with a decreasing speed. The other type of graphs that I should be able to draw or analyze are speed time graphs. Since acceleration is the rate of change of velocity, so the slope of the speed time graph should represent acceleration. If I have a flat horizontal line, so that means speed is not changing, and hence the acceleration is 0. If I look at this particular graph, I can see speed is increasing, so I know it must be accelerating. But since it's a straight line, so speed is increasing at a constant rate, hence acceleration is constant. If I look at this graph, I can see speed is decreasing, hence the body must be decelerating. Since the graph is a straight line, so that means that the speed is decreasing at a constant rate. So the deceleration is constant here. So this body is moving with constant deceleration. Similarly, if we look at this graph, I can see speed is increasing, but being curved, the rate is not constant. And it's becoming more steeper later on, so I know speed is increasing at an increasing rate. Hence, the acceleration is increasing. Here, the speed is decreasing, again at an increasing rate. So I would say the deceleration is increasing. For this particular graph, speed is increasing, but it's less steeper further in time, which means that speed is increasing, but acceleration is decreasing. And over here, the graph becomes less steeper. A decrease in speed means that it is decelerating, and a decrease in slope represents a decrease in deceleration. So this is a graph of decreasing speed with a decrease in deceleration. Now, there are a few more examples of graphs over here. As you could see, it's the distance graph. Being constant means it is at rest. Whereas if it is a speed time graph and a constant speed means it is moving with a constant speed and 0 acceleration. This is a distance time graph. It is moving with constant speed. And this one's moving with increasing speed and constant acceleration. In this particular graph, it's moving with decreasing speed. Since it's a straight line, so it must be a constant deceleration. It's a distance time graph. The distance is increasing. The slope is decreasing, so speed must be decreasing. Here, the speed is increasing. The slope is decreasing for a speed time graph, so that means that the acceleration must be decreasing. So speed is increasing, but acceleration is decreasing. Here, the speed is decreasing, but if you look at the slope, it's more steeper here and less steeper here. So that means the speed is decreasing at a decreasing rate, or deceleration is also decreasing along with speed. If you look at this particular graph, we can see that the distance is increasing and also the slope is increasing, so that means the speed is increasing. Here, it's a speed time graph. Speed is increasing, slope is increasing, so that means acceleration must be increasing as well. So both speed and acceleration are increasing in this graph. Here, speed is decreasing, but it's becoming more steeper, so deceleration must be increasing. Now, in this particular situation, if I have an object moving along a straight line with a constant acceleration in the opposite direction, so what's going to happen is that the object's going to keep on slowing down at a constant rate. It will come to rest eventually, and then it will start traveling in the opposite direction. If I draw a speed time graph, then since the speed is only magnitude without direction, so the speed initially decreases, it comes to rest, and then again starts increasing. But the graph doesn't show opposite direction till I make a velocity graph where when speed increases in the opposite direction, the velocity changes with the opposite sign. If I release an object under the influence of gravity, it only experiences weight, and the acceleration due to gravity is fixed and constant, which is 10 meters per second square. So since the acceleration is constant, so it's going to continue to move with constant acceleration of 10 meters per second square. The speed will increase. If it is released, initial speed must be 0, and the speed is going to increase. And the slope of this particular graph represents acceleration. So a constant acceleration means a constant slope here. Also, as it falls, the distance must be increasing. I can show an increasing distance. But since speed is increasing, so slope of this graph must be increasing. So I should show a graph with increasing distance and increasing slope to represent increasing speed. Whereas if an object is thrown vertically upwards, it would go up and come down, and it will experience a constant downward acceleration of 10 meters per second square. As it goes up, it slows down, speed becomes 0, and then when it starts to come back down, the speed again increases. If it is a velocity graph, then I have to show the change in direction with the negative sign of velocity. An object might be released in the presence of air resistance. In that situation, although the weight is a constant force, but the air resistance depends on speed. So as the speed increases, the air resistance would continue to increase, and hence the resultant force would continue to decrease. And because of that, the acceleration would also decrease. So the speed will continue to increase, but the acceleration would continue to decrease, which means that it should be increasing speed graph with decreasing slope. Eventually, the weight and air resistance become equal. The resultant force becomes 0 and starts moving with constant speed, which is also called terminal speed or terminal velocity. If it's a parachute is falling down, then right after the parachute opens, the body slows down rapidly and acquires a smaller terminal velocity. This is the point where the parachute opens and the speed suddenly drops, the speed suddenly drops because the moment parachute opens, the air resistance becomes bigger. It slows down, the air resistance starts becoming smaller and smaller, and eventually again becomes equal to weight. But by that time, the speed of the object has become lesser. Now we can talk about some examples over here, like a question could come where I've been given an axis, a pair of axes, and I have to sketch a graph for an object falling under gravity in the absence of air resistance. Since there is no air resistance, speed should increase at a constant rate. That's because the acceleration is constant. And distance should increase at an increasing rate. That's because the speed is increasing. For another example, the object is projected vertically upwards in the absence of air resistance. So as it goes up, the speed would decrease. It becomes 0 at the highest point. When it starts coming back down, the speed increases again in the opposite direction. And as it goes up, the distance would increase, but as it comes down, the distance would decrease, and when it lands to the ground, the distance again becomes 0. At the highest point, the speed becomes 0, so a tangent to the graph would be a flat horizontal line. As it goes up, the distance is increasing, but the speed is decreasing, which is being represented by the slope of this graph. So the gradient of this particular graph is decreasing, which means that the speed is decreasing. Whereas over here, the speed is increasing on its way down. Now we have to sketch a graph with air resistance. So if there is air resistance, the speed would increase at a decreasing rate, and then it will become constant, which is the terminal velocity. The distance would increase at an increasing rate because speed is increasing. And finally, it becomes a straight line. That's because the speed is constant, so slope of the distance time graph would become constant as well. Let's have a look at some of the past paper questions. It says the diagram shows a parachutist in 4 different positions as she jumps from a high balloon. At which point does she have a terminal velocity? Not yet moving, of course it doesn't have terminal velocity. Accelerating is not terminal velocity because terminal velocity is when it's moving with constant velocity, which is happening in option C. Not accelerating means constant velocity, and hence that must be the terminal velocity. Let's have a look at another question. It says, which graph represents the motion of a body falling vertically that reaches terminal velocity? It's a speed time graph. So when it reaches terminal velocity, the speed becomes constant. So the speed initially increases and then it becomes constant, which is shown in option B. So I'll be able to pick this option as one in which the terminal velocity has reached. In next question, it says the speed time graph of a falling skydiver is shown below. The skydiver alters his fall first by spreading his arms and legs and then by using a parachute. At which part of the graph the diver shows falling with terminal velocity? So you can see that this velocity could not become constant. Still about to become constant, but it hasn't become constant. Whereas in option D, it is a flat horizontal line. So the velocity has become constant here. So you would say this is the velocity, which is terminal velocity.